All right, to start with, I'm going to review the process here from beginning to end of how you do these problems. Today is kind of a review day. Then tomorrow is officially a review day. And then the test is on Friday. That's the plan right now. So these are not easy. And we did a huge day yesterday where we had to kind of learn everything. So I'm going to break this down into little steps. For instance, if you can't graph this, and by the way, solve it first, then you're going to have major trouble on the test. Okay, so let's get that solved for y. That's an easy one. Solve it for y, and then graph it. And notice it has a less than sign. Not a less than or equal to, a less than sign. Graph it, shade it, and then I'm going to give you a new one to try. Okay, so first step, subtract 2x from both sides. And you got y is less than negative 2x plus 8. Then, to graph that, you need to know where to start. Start at the y-intercept, which is 8. So I'm going to put a spot there and call it 8. And then I have a slope of negative 2. It falls 2 and runs 1. Falls 2, runs 1. Falls 2, runs 1. And so basically it looks something like that. And then, should it have a solid line? No, it should have a what? A dotted line or a dashed line, or however you want to say that. Okay, so I'm going to make it dashed in black there, and then I'm going to shade which way. It says less than. Below. All right. Now, let's say that we had another line, and I'm just going to have this one already pre-solved for y. It's going to be y is less than negative x plus 6. I'd like you to put that on the same graph. So you're going to put it on the same graph because we're going to want those two lines to cross. The next question is, how do you tell where the two lines cross? I showed you how to do it with algebra, and I showed you how to do it with a calculator. I'd recommend using the calculator to graph this and see where those two lines cross. Okay, so it involves two things. Yes, it generally looks like this, but the question really becomes, where do those two lines cross? If you don't know how to put that into a calculator, ask the kid next to you. Put it in, solve it. I want the answer as like this comma this. Okay, I'm going to pause for a second. Let me give that a try. So, when you put it in your calculator and you set y equals this and y equals that, and you saw where they cross, these are such nice numbers, you probably didn't even have to change the what? What's it called? The window. Good. But in a moment, you're going to be graphing something where it goes as high as 1,000. Do you get? You'll have to change the window. Everybody hit the window key on your calculator. You see how it says x min? If we're talking about like muffins and things, can you have negative muffins? No. So you're never going to have any negatives, so you probably go from 0 as a minimum to, and the next problem that we do has, again, it goes up as high as like 1,000. So your x max will be, well, if it goes to 1,000, you better go beyond 1,000 so you actually can see where it touches, right? So if you need to go to 1,000, go to like 1,200, yeah. Okay, same with the y's, from 0 to 1,200. I just want to warn you ahead of time that the next graph we do is going to go way bigger. All right, but when you hit second calculate, the thing right above trace, you had choices and you hit intersect, right? What did you get when you hit enter, 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 and it's got the final answer? The intersection point was at what? 2, 4. Now, do you think you could have solved this one with algebra? Yeah, there's such nice numbers. It would have been pretty easy to solve. Just a quick reminder, what would you have done? Well, y is equal to this, and y is equal to that, and therefore I can take this y is equal to and put it in here, because y's are equal, right? So it would be negative 2x plus 8 is equal to, and you start with equals. I know there's a less than sign there, but negative x plus 6, and you solve, and you'd find out what x was, then you go back and stick it into one of the other equations wherever you have your x, and we figured out the x was 2 after you solve that, and then you go back and put it into one of the other equations, and let's say I put an x is 2 right here. It's not hard to tell that y would have to be 4 then. Okay, so that's how you would have done it with algebra. All right, so then, at the end of these questions, there's usually something like Optimizing. All right, let's talk about that for a moment. So let's say that your problem is about banana bread at the Cove. We're going to put banana bread down here. And let's say the other thing that you are considering buying is some chips. Okay, banana bread versus chips. We'll make this X and we'll make this Y. All right, the optimizing thing would be like this. Do you get that they charge you like $1 something for the banana bread? $1.50, $1.60, something like that, whatever it is. So then let's say that of that, they make $1 of, I guess you could call it profit. Like it doesn't cost that much to make banana bread, right? So they make money. That's not wrong. They have to actually pay the person who's handing you the banana bread. That's part of it. And if they make any profit, I think what happens is it goes to support like the school lunch program, so that basically you can get better lunches. It's not like somebody in the background is going, "Oh, I made a ton of money and I'm going to go buy a Porsche." It doesn't work that way. So they'd use the money for something else. So for the banana bread, let's say that you're making $1 profit on the banana bread. Well, the chips only cost like 75 cents, and so there's no way there's 75 cents of profit on the chips. They have to buy the chips from the company, right? So let's say there's 50 cents profit on 50 profit on chips. I want you to write me a profit function for the Cove. It's not that complicated. It just involves X and Y and the numbers we just said. The profit function for the stuff they sell at the Cove, the chips and the banana bread. They don't tell us everything. This isn't one of those where they say, "Oh, and you're going to make this much profit each day." It doesn't say that. So, how much for each X? 1 for each X, plus how much for each Y? 0.5 for each Y. There. Now, imagine for a moment that the way our graph looked was something like this, and the kid, based on certain constraints, he only had so much money to spend, and he likes banana bread maybe more than he likes chips or whatever. You've got some equations. We'll practice writing those in a minute. These 3 choices were what we had, and those are the 3 corners of the feasible region, the vertices, right? And let's say that one we just did, 4, 2 was on there. Let's say this one's at 0, 5. And lastly, the other corner here will be at 7, 0. My question is, okay, would you please figure out how much profit the vertices of the feasible region would yield? What I mean is, there is only, I can't seem to move that, but I wanted to move it up. How about if I move everything else down? Yay, I can do that. Okay. For this corner, we will make this much. For this vertice, we will make this much. And for this vertice, we'll make that much. Figure out the profit at the 3 different vertices of the feasible region. Why am I not even testing 0, 0? Because there's no profit if you sell nothing, right? Yes, this is a corner, but there's no way that's the most profit for them. Figure out the profit at each vertice. I'm going to pause for a second while you try that. All right. So you should have checked these 3 points, 0, 5, 4, 2, and 7, 0. How many of you actually knew how to check them? All right, good. Seems like most of you. So if I put in 0, 5, I like to do it this way. I'm going to put in an empty framework of the equation, and I'm going to drop in my X is 0 and my Y is 5. 5. So that would be 25 for that. They'd make $25 profit on that scenario. Oh, 0.5. 0.5 times 5 is quite different. That's 2.5. But of course, we all know the Cove deals in millions. 2.5 million of profit right there. 4 comma 2, just save me some time. 1 parentheses 4, help me, what was this one? $5? Okay, how about the last one? So therefore, 7 wins, and 1 times 7 plus 0.5 times 0. And yay, I have optimized the profit with 7. And then it's, honestly, for the cove, it could be per minute, like during passing times. You know what I mean? So, yes. Look, what do we pick? 7, 0. That's this one. Is that only chips or is that only banana bread? It's only banana bread. That's the only banana bread scenario. And it makes sense. You can make more on banana bread. So, of course, you're going to get the most profit when the kid buys the most banana bread. Okay? All right. So, that is a typical set of questions. Here's the things that I think kids are going to struggle with. Number 1, they're going to have an equation like this. And they're going to have to solve it for y carefully to make sure that when they graph it, that they know where it goes. You can't graph it until it's solved for y. Okay, that's one thing. It's not that hard to solve for y, but I'm afraid kids are going to mess up this little negative on the 30 and all that kind of stuff. All right? The second thing I'm afraid about is that kids are not going to know how to actually write the equations, and it's partially because there's this like flaw in everybody's head about how these equations work. So if I say, for instance, that there's 5 times as many dogs as cats, and I ask you to write the equation, this is what people are going to write. And if I say at least 5 times as many dogs as cats, they're probably going to write it like that. Okay? But that's not right. You can tell from the way I said that that must not be right. Why isn't it right, though? If there's at least 5 times as many dogs, it seems like I should just write it just like that. But let's actually get some numbers. If there's 5 times as many dogs, maybe there's actually 5 dogs and there's 1 cat. Is that a scenario where there's 5 times as many dogs? Now, if I actually put in the numbers, watch what happens. Dog, 5, cats, 1, and 10 is not equal to 1. It's not even close to equal to 1. Sorry, 25 and 1 are obviously not equal. So what it is, if it's 5 times as many dogs as cats, you go like this. You actually have to times the cats by 5 to make them equal to the dogs. See what I'm saying? So 5 times as many dogs as cats, you actually put the 5 on the cats. Now let me prove it. These are 5 times as many, right? So I'm going to put in 5 for the dogs and 1 for the cat, and see, it's actually equal. 5 equals 5. So there's a human nature element that says, if I say, I really think our Tino's down the street should make 3 times as much pizza as anything else, because it's supposed to be a pizza joint, right? So 3 times as much pizza as they're actually going to start selling hot dogs. Did you know that? So, ew. Okay, so some of you obviously aren't going to buy the hot dogs, but some of you will be like, oh, Chicago dogs, I love those things. So anyway, if you're going to sell 5 times as much pizza as hot dogs, you're going to be tempted to say that. Pizza compared to dogs. But remember, it's the other way. Okay. So with that preface, now we'll see if you actually remember that in a moment. Would you solve this one for y? We'll handle that kind first. Just make sure you know how to solve properly. Pausing while you try that. All right, so here we go. You should have said negative 60x, and then you should have said negative 30. Here's a key moment. Kids think that negative somehow went with the 60. It didn't. Don't interrupt, please. Raise your hand if you want to say something. And negative 60x plus 480. And then I'm going to divide everything by negative 30. And then I will get y is, and I just divided by a negative. How many of you guys remember to switch the sign around? Ooh, a lot of you. All right, I know it wasn't everybody. And 6 divided by 30 is 2x. And then negative, and then I have no idea what's 48 divided by 3. Thank you. So it comes out to 16. All right, so final answer, that then can be graphed. It looks totally different than that we started with, doesn't it? All right, so if you aren't able to solve those, I want to make sure we talked about that. Now the writing stuff. I wanted to leave enough time for you to forget what I just said, and hopefully you don't, but let's say that you are going to be selling at a movie popcorn, which will go with P, and candy, which will go with C. Let's say that you know from past experience that you sell about 3 times as much popcorn as candy. Write the right equation for that. In fact, I'm going to make it a greater than or a less than sign. At least 3 times as much popcorn as candy. And that has to turn into a math equation. And my best advice to you on these, I even get confused. I've been teaching this for 20 some years, and I get confused about which way to put that stupid sign. Whether I should say a less than or a greater than, because maybe I move it from this side to the other side. I get confused. So what I do is I will make up some numbers that would be at least 3 times as much popcorn. I'll make up some numbers. And then I'll stick them in my equation, and if that works, then I know I did it right. So check yours by sticking some numbers in that would be at least 3 times as much. Make up some data. Stick it in your equation. It's kind of like the whole XY chart thing. You know, you stick the numbers into your equation, see if it worked. It's very easy to mess this up. Raise your hand if you are done and you've got an equation. Okay, let's see if you did it right then. So the thing I was trying to tell you is the common mistake is people will go 3 times as much popcorn as candy, and then they throw in a sign and they don't know if they did it right, okay? That's not right. And here's how I can prove to you that that's not right. Let's make up something that's 3 times as much popcorn as candy. Okay, that would be like 30 popcorns and 10 candies. Right? Now, if I stick that in this equation, we'll see if it actually worked. 30 and 10, and look for the equals here. Not the greater than sign, but the equals. Is this equal? Is 3 times the P, that'd be 3 times 30 is 90. 90 is greater than 10, can't argue with that, but look for the equals, because we tried to make it a 3-to-1 ratio. So, I tried to tell you, don't succumb to the urge to say 3 times the P. It's actually 3 times the candy. Now we'll see that my numbers, when I stick them in, will come out right. 30. No, candy was 10, sorry. Candy is 10. 30 for popcorn. And now it actually equals just like it should. Okay? Now, I did say at least 3 times as much popcorn. Do you get I could make this a 31 and it would still be at least 3 times as much? That's how I'm going to test to see if I got the sign the right way. I'm going to make this a 31 and a 10. 31 on the popcorn and a 10 here. Now, is the sign this way? Is that the right way to have it? Yeah, it worked. Do you get if I had the sign the other way? I'd be looking at a false statement. 31 is not greater, or sorry, less than 30. It would have been a false statement. So therefore, I would have known, oops, I did the sign backwards. All right, so the only way you're going to know for sure, in my opinion, is by taking some numbers and sticking them in your equation and see if it works. All right, let's make another one that's like that. Except this is the popcorn and the candy, except we're going to have prices on it now. Let's say popcorn costs $5 and candy costs $3. Let's say you have $20 to spend. That means you can't spend more than 20. All you have is a $20 bill. You don't want to be that person that like spent $20.40 and like, can you just give me the 40 cents? No, we're going to say you have to spend 20 or less. Write me an equation. that would give you, and now don't try to mix in this 3 times as much. That's a different equation. Some kids try to put it all in one equation. You really can't. And you can, but you don't want to, because we have separate equations, because we get a graph that looks like this with separate lines. One line goes this way for that one thing, and then a different line goes this way for the other thing, and we see where they cross. This equation is about, just about, spending your 20 bucks. Write me an equation. If popcorn's 5 bucks, candy's 3 bucks, can you tell for sure how much of each they're going to buy? No. You can't tell if they're going to spend all their money on popcorn and get 4 popcorns, or if they're going to spend all their money on candy and get 6 times 3 is 18. I guess that's the best you could do, is have 2 bucks left over. But that's what an equation does for you. 5 bucks for each popcorn. I'm going to call it a P. We don't know if it was X or Y. Okay. Plus 3 for each candy. This will be less than or equal to 20. Raise your hand if you wrote that one right. Okay, good. All right. So I've run you through all the things that people usually get tripped up on. One is making those equations. That whole thing where it's backwards in your head. 3 times as many dogs, don't put 3D. You times the other one by 3. Okay. And solving equations like this. If I asked you to solve that for C, some kids will mess it up. Try solving it for C right now. Solve that one for C. So let's say that in our context, candy is the Y. So you'd solve for C. C is less than or equal to negative 5p plus 20. Why did I put the p first? Because then it makes it look kind of like a slope. You didn't have to do it that way. Final answer, C, less than or equal to negative 5/3. P plus 20/3 is an okay way to say it. If you wanted to, you could say 6 2/3 at the end there. Raise your hand if you had that one right. Okay, awesome. Then let's actually jump into the homework for today. So I'm going to pause for a second and pull that. Okay, so we found the worksheet for today. Just so you know what it looks like on the top here is Linear Programming Day 3 Optimization with Linear Programming. We are skipping over the Mrs. Wilson's vitamins, going on to Magician's Payment. All right, this is a problem that I want you to do from beginning to end. As in, the first thing is figure out which is X and which is Y, but they tell you that. Cool. X is student tickets, Y is non-student. Why did they just call it adult? But I guess maybe they have a rate for little kids that's the same as adults, whatever. Okay. Now, since you know what X and Y are, your equations are going to be stuff like this. That kind of stuff. Okay? Or what if it's 2 for this and 5 for that, and adding up to less than or equal to 4,000 in money? Okay, so I don't want to lead you here too much. I want you to see if you can get these equations without my help, because that is a typical question that'll be on your test, not tomorrow, but the next day. We have one more day of review. Big test tomorrow, or big test Friday, sorry. Okay, I'm going to pause for a second while you try to make me these are called constraint equations. Okay, to keep you from going too far the wrong direction, attendance of at least 1,000 is X a number of people that will be there, or an amount of money. Think it through. Look at what it says. Is X an amount of money, or is X a number of people? It's a number of people. So this number of people plus that number of people needs to be at least, does that sound like greater than or equal to, or less than or equal to? It's 1,000 obviously, but I think the number of people should be less than 1,000. It says at least 1,000. Does that feel like less than or greater than? Greater. That's important. Could it be 1,000? Yes, because at least means that it Could be 1,000. There you go. There's your first one. Next, the next one involves money. And so right away, kids think the same thing as x plus y is at least 4,800. But no, this is money. And this is people adding up to money. That doesn't make sense. It's kind of like that, but you need to put a money element for each person. Basically, the ticket price. Figure out how to put your money in with the x's and y's. Who's already got that? In the back corner, what do you say, Kay?
Excuse the interruption. That's David O'Cleary.
All right. So anyway, sorry about the interruption there. 4x plus 6y is, what were you saying again? You were finishing the equation, is correct. And that's in dollars. Now, do you really need dollars in your equation? No, because your calculator's not going to know those are dollars. So you don't need to put that dollar sign there. Okay. You needed to know, though, that this was about a number of people, so it was just x's and y's. And this was about money, so you need that little money component in the front of both of them. Okay. Now, when you graph this thing, I'm going to warn you something about how it looks. It's going to be like this, but when you actually do the shading's going to be all out here, which is kind of strange. That means this is one of the corners of it, but this, do you get how that is not on the edge of the feasible region? So people often think that's one of their points. It's not. That is, though, and that is. Those are your three corners of the feasible region. Why does it just keep going? It seems like it should be stopped by something. But our problem just says there'll be at least 1,000 people there. They don't ever limit it and say that, by the way, the most we could hold is whatever. Okay, so therefore there's no limit on the edge of this shape. So unlike most of them where you just shade in like a triangle or something, this one goes forever. And therefore he has unlimited upside. If he can get 100,000 people to show up, lucky for him. Okay, your problems 2 and 3 are due tomorrow. I'm scared that some of you are going to go, this is really hard. I'm going to watch Netflix instead. When it gets really hard, that's the moment where you're going to earn the A by actually practicing tonight. So make sure you do your homework. That's all I got for you for today.